Find the equation of the tangent line to the graph of x squared minus 5xy squared minus 7y to the fifth equal to 1 at point 2, negative 1. Now, this is an equation, and you have to find the tangent line. Tangent line requires the point slope form. And in order to figure out this slope, you need to know the derivative. So this question is really about finding derivatives, but the problem is y is a function of x if you solve this for x, which is impossible to do, because I certainly know how to solve a fifth order equation for y. So because this algebraic expression, this equation, is so hard to solve for y, the only way to figure out the tangent line slope is to find the derivative by using the implicit differentiation. Okay. What is the implicit differentiation? Implicit differentiation means that you differentiate everything as a function of x. So you differentiate everything, and it really means you differentiate it with respect to x. And that's important because there are two functions here, two variables here, x and y, right? So you're trying to differentiate by x while realizing that y is really a function of x. See, if you solve this equation, although we can't, but let's hypothetically say we solved it for y, then it will be a function of x, right? And whenever you see y, you shouldn't think of it as y, but y which depends on x, okay? Now this small point is going to be a very important thing to know when you do the calculation, as you will see. So we differentiate both sides. We're going to differentiate term by term. And x squared, if you differentiate by x, well, the derivative is 2x, that everyone knows. On the other hand, when you see this, I want you to think about this as 5x and y squared. These two things multiplied, okay? And if you see two things multiplied, then you have to use the product rule. And here's actually where we're using this fact. Y is a function of x, right? So y squared is also a function of x. Y squared is something that depends on the value of x. 5x also depends on the value of x. So you have two functions multiplied together. How do you differentiate it? Well, it's a product, so you must use the product rule. You have no choice. You have to use the product rule because there's no way to write this as a non-product. It is a product, so there's no choice. So we apply the product rule. And then minus, here is the number 7. 7 is a constant, so I can pull it outside, and I just have to differentiate y to the 5th power. And 1 is a constant, so if you differentiate, that's equal to 0. Okay, let's carry on. 5x prime. X, if it differentiates to 1, so you just get 5 if you differentiate. And here's another part that you have to be very careful about. What is y squared prime? So let me do the calculation over here. What is y squared prime? Well, as I said, y is a function of x. So what you really have is like y, which is a function of x, nested inside the square function, and you're differentiating it, right? So if you cover this, you remember the chain rule, right? You cover this as a big X, then you see this as x squared, which is 2x. So you write down 2yx, and then you pull the inside function out and you differentiate, right? So I'm using the chain rule. What's the chain rule? If you have an inner function and you have an outer function, you differentiate the outer function as if this inner function is just x. So in your mind, you're thinking of x squared, you differentiate as 2x, but instead of x, now you have y of x. And once you're done, that inner function has to be taken outside and you have to differentiate again, okay? Which means that this is equal to 2y prime, okay? So there is a very big asymmetry between how you treat x and how you treat y in implicit differentiation. And that's actually the reason why so many people stumble when they have to do implicit differentiation. For so long, they were thinking of x and y as like something similar. They're both variables, right? But when it comes to implicit differentiation, you treat x and y very differently because y is actually a function of an x. So you have to write down y squared prime as 2y y prime. Okay. All right, so let's do the same thing here. Y is a function of x, right? So differentiate y to the fifth as if it's a function of y. And we just use the power rule. Power rule says 5 comes down, and you subtract 1 off of that power, so that's 4. But then realizing that y is not a variable, but it's an inside function, you bring the inside function out, and you have to differentiate it. Okay, that's how you treat y. So to recap, what I'm trying to say is that whenever you have to differentiate a y, first differentiate as a function of y, but then attach your y prime at the end. And it's that easy. Okay, so maybe I should just say that again. If you want to differentiate y to the fifth, just differentiate as you would normally do, 5y to the fourth. But then, don't forget, you need to attach a y prime, okay? All right. So with that, and another big source of mistake is forgetting this parenthesis, okay? If you forgot this parenthesis, then you'll make a sign error, but we didn't. So we can now distribute the negative sign, and here's what we have. 2x minus 5y squared minus 5 times 2 is 10, so 10xy y prime minus 7 times 5 is 35 y to the fourth y prime equal to 0. Okay. Now here comes the next challenge. The next challenge is we need to solve this for y prime because we have to find the slope of the tangent. Slope of the tangent is the value of y prime at the given point, right? So we have to solve this for y prime. And what you do is to solve for y prime, first you have to identify the terms that have y prime. Okay, so here's y prime, and here's y prime, right? These two terms have y prime, whereas these two terms don't. Okay. If you ever had played or watched people playing shirts and skins in the playground, right? Playing basketball, shirts and skin, and then you see that some people have their shirts on, right? Y prime. Think of y prime like a shirt. And others don't, okay? And they have to play, so they will be separated from each other, okay? So I think that's a good analogy. So I need these highlighted ones to be separated, so I'm going to move these to the other side. So you have 10xy y prime plus 35 y to the fourth y prime, because if you move, the signs change, right? And the reason this works is because by now you can see that since we've moved all of those that had y prime on one side, these terms can be factored by y prime. You can factor the y prime out. And that gives you a perfect opportunity to solve for y prime. Let me show you why. So I'm going to factor out the y prime, and since I'm out of room, let me copy this again. 2x minus 5y squared equals, you have 10xy plus 35y to the fourth y prime. That's what I had. And I'm going to divide both sides by this thing in front of y prime, because my goal is to isolate y prime, right? To solve for y prime means I want to isolate y prime, so this thing that's multiplied to y prime has to go, okay? So I divide that both sides, then these will cancel, And the result is that you get y prime as 2x minus 5y squared over 10xy plus 35y to the fourth. Okay. Now here is the important part. So what is the slope? Well, slope is not this. So don't get confused. Y prime gives you the slope as a function. Okay? Y prime is a slope as a function. To actually get a slope at a given point, which is 2, negative 1, you have to evaluate this y prime at that given point. So what I need to do is slope m is now 2x minus 5y squared over 10xy plus 35y to the fourth, evaluated at 2, negative 1. Now, what does this mean? Evaluated at 2, negative 1. Well, you see, this is the x coordinate, and this is the y coordinate, right? So to evaluate this function at 2, negative 1 means that you have to plug in 2 into x and negative 1 to y. So let's continue on. That would be 2 times 2 minus 5 times negative 1 squared over 10 times 2 times negative 1 plus 35 times negative 1 to the fourth power, which is, you get 4 minus 5, which is negative 1, and then that's negative 20 plus 35, which is 15, so you have negative 1 over 15. Alright, so what did we achieve? Well, we achieved the following. We found out that the slope is negative 1 over 15, and since the point is 2, negative 1, the point slope form can now be applied, and we can write it as y minus y, so this is x naught, y naught, so it's negative 1, so y minus negative 1 equals to negative 1 over 15 x minus 2. Okay, and to give an answer, you should solve this to turn it into slope-intercept form. So you're going to get negative 1 over 15x if I multiply this together. If I multiply this, that's negative 1 times negative 2, that's positive 2. So it's positive 2 over 15. And when you bring this is plus 1, right? But if you bring this to the other side, it's minus 1. So the final answer, I'll put the answer here. Answer is y equals to negative 1 over 15x. This is 15 over 15, 2 minus 15, that's negative 13. So it's negative 13 over 15. So that's the final answer.